Welcome to Room 9, our region's largest classroom. My name is Jeanne Norris, and today I'll be teaching science for 3rd grade, but learners of all ages are welcome to join me. I'm so glad you're here today. As you can see, we are outside, and I thought it would be fun to start by checking out some of the weather tools that I created last week. Did you happen to make any of them yourself? Well, if you did, maybe you caught some rain like we did. As you can tell, I am wearing a big heavy coat, and that's because it's pretty chilly outside. And it's been very gray over the past week and also a bit rainy. So you can see we got a lot of rain over the last week, about 3.5 inches. That is a lot of rain. And we're gonna get even more rain next week. Well, today we're going to go ahead and explore climate a little bit more. So let's go ahead and go inside and explore some data in a book that I found. Okay, so we're going to start off a little different today. We're starting off with a book because this book, which is called Climate Maps, and let's see, it is by Cynthia O'Brien and it is published by Crabtree Publishing. This book had a data chart or picture in it that I thought looked really interesting and could be our phenomenon today. You know, phenomena are just things that we notice. They are observable events in the world. And actually data can be a phenomenon. So we are going to look at this data and notice and wonder about this data. So why don't you come and take a look with me. I saw this picture and I just had so many observations and questions about it. I'm only focusing on this box right here, this box that shows the map of the world, and it is titled Climate Zones of the World, and then it has a legend. A legend is something that can show you what different things mean on a piece of data or a map that you're looking at. So in this particular case, we are looking at different types of climates around the world. And some examples would be polar, which is kind of this bluish purple, temperate, which is green, desert, which is yellow, Mediterranean, which is orange, tropical, which is like a dark reddish color, and mountain, which is black. And so what I want you to do is to notice everything that you can about this data. What do you notice? Well, I notice that polar climates are up here, and they're also down here. And I don't see polar climates anywhere else. What about you? Do you notice that? Let's see, what else do I notice? I notice that the temperate climates are kind of spread out. So there's some here, here, here in Europe, here in Asia. There's a little bit in Australia, like near Australia. I also noticed that the desert climates are spread out, but just like temperate, they're kind of in the middle part of the map. So there's some desert here in North America, some desert in South America, a lot of desert in Africa, a lot of desert in Australia, and some in Asia as well. I noticed that Mediterranean climate is not very common. Like, it's just in little bitty pieces. So here's a little piece of Mediterranean climate in North America. Here's another little piece here. Here's another piece here, and some other pieces here and here. And I notice, I don't know, it seems like these Mediterranean climates are on a coast near the ocean or near a sea. That's the Mediterranean Sea right there. Maybe that's what it's named after. What do you think? Here's another near the ocean. And then I noticed that tropical is all around, but it's really more towards the middle of this map. So there's some in Central America, South America, Africa. There's a lot in these two continents. I noticed that there's some tropical here. And then the mountain I noticed is also not very common. So there's some on pretty much every continent. Well, actually, there's no mountain climates in Africa that I can see, Australia or Antarctica. What else do you notice? Anything else? Well, what do you wonder about this data? I wonder, why is there such a little amount of Mediterranean climates? Why is there so few mountain climates? Why are the polar climates only at the top and the bottom? Why are the tropical climates and the desert, well, let's say the tropical climates only towards the middle? Why is that? What else do you wonder? Does the ocean have anything to do with the Mediterranean climates? Maybe you're even wondering, what is climate? All right, so that brought up a lot of questions for us, and I thought that we might start off with a really basic question. What is climate? So I started my journey here by thinking about what weather is, and we reviewed what weather is in the previous episode, and this book told us, this book is called What is Weather by Robin Johnson, published by Crabtree Publishing, and this book told us that weather is what we experience day to day, and it might change. It might be sunny, it might be rainy, it might be snowy, it might be a storm, you know, things like that. So weather is what we experience day to day, but we're wondering, what is climate then? So this book does have a page about climate, and we can read it. Now, sometimes scientists like to obtain information or get information from books to help them better understand. People who have gone before them have researched this stuff, they've put it in a book so that way other people can learn from it. And so that's something that we're going to really focus on today as scientists. So this book says, what is climate? Weather changes from day to day, but climate does not often change. Climate describes the usual weather pattern in an area. That word pattern is very important. Climate can determine where people live and the crops they grow. Earth has 4 main climates. They are polar, temperate, dry, and tropical. So this book, we can record some of the information that we find from this book, and I think that I would really like to record what climate is. So I'm going to record it here. Climate is the usual weather pattern in an area. Okay, that's the definition that we'll go with from this book. And it does tell us that Earth has 4 main climates. Now, we know from the picture that we just looked at that it can even be broken up into smaller categories. They break it up into 6 categories, but this book only breaks it up into 4 categories. And sometimes you find that when you read books, different authors have different ideas about what they want to say about the particular science. And some books might go way deeper, and some books might give a very simple answer like this book gives, and that's okay. The more that you learn, the more that you read, the more that you'll find little differences in information like that that you can use to even take your learning even further. So let's read what they have to say about the different types of climates. Dry climates have very little rainfall. Temperatures are hot during the day and cold at night. Temperate climates have weather that changes with the seasons. Areas with polar climates are cold and covered with ice and snow all year. Tropical climates are very hot and rainy all year long. So of these 4 different categories of climates that they have, which category do you think that you fall under where you live? Well, I think in St. Louis, Missouri, where I live, that it would be temperate climates. We have weather that changes with the seasons. We have 4 seasons, and they're very distinct: winter, spring, summer, fall. And I think that that means that we are in a temperate climate because we do get rain. There can be many, many days of rain. We aren't cold and covered with snow all year, and we're not hot and rainy all year long. So I think temperate fits us best. All right, so this book really, that's the only page that discusses the climate. And so I am done with this book. I've gotten what I'm able to get from this book about climate. Another book that I found about weather and climate is called Catastrophic Weather. Do you know what that word means, catastrophic? It means that it's like very destructive weather. Bad things can happen during catastrophic weather. And we're going to be exploring that topic more in the next episode, but we will take a look at one page that I found in this book that might be helpful. So this book is by Sarah Levete, and it is Crabtree Publishing that published it. And it says, most people know roughly what type of weather to expect in a particular season in a certain region. This pattern of weather is the climate. Hey, that's the same as what we read, right? So that's a matching definition. The usual weather pattern in an area is the climate. The climate depends on a region's distance from the sea, the height above sea level, called altitude, and its position from the equator, an imaginary line drawn around the middle of the earth. Have you ever heard of the equator before? So areas near the equator are nearer the sun and receive more warmth. Oh my goodness, that's a lot of important facts that I think that we might want to record, okay? So I'm going to go ahead and do that. I'm going to pause because I don't want to forget this. This is really important. And I'm going to call this, what do you think? What should I call this? I'm going to call it factors that affect climate. Or maybe we could even just simplify it and say, what affects climate? And I'm just going to do like kind of bullet points here, okay? So what affects climate? The distance from the sea, here's another thing. The height above sea level, called the altitude. That's a big science word. Altitude, or we'll say height above sea. And then there was one more thing I think I saw. Position or distance from the equator. And remember, the equator is that imaginary line in the middle of the earth. And we'll take a look at what that means in just a minute here. Okay, all right, that's really helpful. Let's go ahead and take a look at the book that we started with. So we've so far looked at 2 sources to find some information, and each one had different sorts of things it was telling us, and we've recorded some of the things that we've taken away from it. Now let's take a look back again at this Climate Maps book by Cynthia O'Brien, and we are going to see what they have to say. This book, I mean, you can tell by the title, it's focused on climate maps, and so it's really a lot about data. And so you might learn about different maps in social studies, for example. You might learn about physical maps or political maps. So political maps show countries and cities, and physical maps might show mountains, rivers, and lakes. Well, a climate map can tell you about different weather patterns in a country or even the world. And this uses a different word. It says climate is the average weather in an area over a long period of time. So average or typical, let's say. So I can even, usual, we can also call it average or typical. Okay, so it added to our definition a little bit. Climate includes temperature, or how hot or cold an area is, and precipitation such as rain or snow of an area. Weather changes from day to day. One day could be sunny, the next it could be raining, but climate is what people expect in a certain place in a certain time of year. So if you are watching this episode, think about what season you are in right now. What type of weather do you expect to see in that season? I'm in fall right now, and so I expect it to be cloudy, cooler, maybe a little bit rainy, so that way the trees can get extra bright. So that's the type of weather that I would expect, and that's because I live in a temperate climate. Remember that word temperate, meaning not too hot, not too cold, maybe sometimes where it is hot, sometimes where it is cold, but experiencing all the different seasons. So here's this that we looked at, the world climate zones, and I'm going to kind of zoom in and show you the polar climate. You can tell it looks very snowy. The temperate climate, that might look like, if you're from St. Louis like me, that might look a lot like where you live. We have the desert. We have the Mediterranean climate. Ooh, that looks so cool. I think I would love to live in a Mediterranean climate with the ocean right there by me. Tropical, with a waterfall there, and it's very lush and green. And then mountain. So you can see there's some green down here, but the higher you go, the snowier and less trees you see, right? So those are the different climate zones of the world that this book outlines. So we can maybe record some of those things. So we can say, make sure you can see what I'm doing here. Polar is cold, okay. Temperate, let's say 4 seasons. Desert, hot and dry. We've got Mediterranean. Ooh, I'm going to check myself on this spelling here. I don't want to mess that up. And then we have tropical, which is humid and hot. And then mountain, which is kind of colder. Okay, from the pictures, that's what I can tell so far. All right, let's keep reading. Latitude and climate. So latitude, let's find out what that word means. You might not know yet, or maybe you do. Let's figure it out. The type of climate a place has depends on where it is located in the world. Lines of latitude are horizontal, imaginary lines that are used to measure how far a place is from the equator. Oh, we saw that right here, that the distance from the equator affects climate. So this book is confirming that, and it's giving us a little bit more to go on by saying the word latitude. So here are some lines of latitude. They're going across the globe horizontally, okay? So it's measuring how far a place is from the equator. Here's the equator. This is the equator line, okay? And we're measuring how far away things or cities or locations are from the equator. So above the equator, we call that the northern hemisphere. Below the equator, we call that the southern hemisphere, okay? So the latitude of a place affects how warm it is. Areas near the equator are the warmest. Areas further from the equator are colder. I feel like that is starting to answer one of our questions about, or one of the observations at least that we had, and then question that we had about polar climates, for example. Polar, you think of maybe like polar bear, is very cold. And so it makes sense that we see polar climates at the poles or at the top and bottom of our planet, because those places are farthest from the equator. So that makes sense. So the hottest climates, like we said, desert is hot and dry, and tropical is humid or wet and hot. And so it makes sense that we would see these climates near the equator, right? So the equator, it said it's the hottest, and that makes sense. So climatologists are scientists who study climate, and they are very important people, very important people. They use tools to measure and record different parts of the weather, such as temperature and precipitation. They might build weather stations that'll help them do that recording. And they might make sort of climographs, okay? So graphs that will tell us about the climate. So here, for example, they give you Miami, Florida, and they give you a temperature map and a temperature graph and a precipitation graph. And so you can tell that the temperature, we're going over months here. So here we start in January and end in December on both of these graphs. And you can tell that the temperature in Miami gets colder, just not by much, but by a little bit. It gets colder in the winter and warmer in the summer, and then colder again when winter begins again. So it doesn't change very much because it's Miami, Florida, and if you've ever heard of Florida, you'll know that it's kind of a warmer climate than what we have in St. Louis. And then their precipitation, you can tell that it's lower in the winter, and then it increases in the spring and summer, and then goes back down again when we're in fall heading into winter. So this graph can tell us how climate is going to be in Miami, Florida over the year. And it can tell us how temperature and precipitation change over the course of a year, what we expect to see, the pattern that we expect to see. So because of that, I want us to look at some climographs and see if they make sense based on what we have figured out and what we have read. So we might, you might say, like, you might add here latitude. That's a good vocabulary word to remember. We have altitude, or height above sea level, and we have distance from the sea. So those are the things that we're looking for. So here we have the climograph for Fairbanks, Alaska. Do you know where Fairbanks, Alaska is? Let's go ahead and take a look. I mapped it out for you on this picture, the original picture that we looked at. So Fairbanks, Alaska, it's a state in the United States, and it's way up here though. So here's the United States, the continental United States, and here's Fairbanks, Alaska, way up here. So what would you expect their climate to be like? What do you think? Well, the map tells us polar, and polar, remember, it's near the poles, it's far away from the equator, so you would expect it to be pretty cold. Let's take a close look at this climograph here. Okay, so we have the precipitation and we have the temperature. The precipitation is the green bars and the temperature is the red line. So we have to pay close attention to scale when we're looking at graphs. And so over here we have the temperature in degrees Fahrenheit, and it goes up to 80 degrees Fahrenheit. And the precipitation over here goes up to 10 inches. So in Alaska, in Fairbanks, what do you think about the temperature there? What do you notice about it? Well, much like where we live, it's cold in the winter and warmer in the summer, but not as warm as probably what we experience in St. Louis, right? So even in August, their average temperature is a little bit underneath 70, right? So they don't get very hot, and that makes sense because it is a colder climate than where we live. What about their precipitation? When would they expect the most precipitation, do you think? Yeah, probably in the summer, in July or August is when they would expect the most. But it's still not that much. It's maybe about 2 inches that they would expect. So that is something that you can do. You can look at data to tell the climate of an area. Now let's take a look at one more here. Cairo, Egypt. Have you ever heard of that place before? Let's take a look at where Cairo, Egypt is. Cairo is right here. So it is close to the equator, and so it's called a desert climate, so you would expect that it would be hot and dry. Now look at it compared to Fairbanks. Wow. Now remember, scale is important. This scale goes up to 100 degrees Fahrenheit. So you can tell that in the hottest time of the year for Cairo, it's like almost at 90. And even in the winter, what we would expect as the winter, it's not really winter there. They are still at least about 60 degrees Fahrenheit. So much, much different. And how does their precipitation compare? Remember, precipitation are those green bars. They're almost non-existent. Cairo gets very little rain, and that's what you would expect in a desert climate. There's one more page that I wanted to show you, and it's called Small Climate Zones. So let's read about small climate zones and think about how we can discover this in our own area where we live. Did you know that your backyard has its own climate? It is called a microclimate. Microclimates occur in small areas. The weather can be different in a small place compared to what it is around it. Some microclimates are larger than others. This map of Hawaii shows 4 climate zones. However, if we could zoom in, we would find even more microclimates. A city is an example of a microclimate. Tall buildings block the wind and the rain. In the summer, the sun heats up the concrete buildings and sidewalks. The hot concrete warms the air, making the temperature increase. This process makes cities warmer than towns nearby. Have you ever experienced that before? Maybe you could even collect data about it and think about what the temperature is where you live and what is the temperature either somewhere that's not a city if you live in the city, or somewhere that is a city if you don't live in the city. You could think about those things. You can also, if you are taking a walk around, think about the climate of a shadier place that has a lot of trees compared to a climate that is very sunny with not a lot of trees. So in our next episode, we are going to think about catastrophic weather or weather hazards and sort of think about solutions to those weather hazards. And in the meantime, I hope that you keep on noticing and wondering. Remember, that is the most important thing that you can do in this world. All right, see you next time.
Teaching in Room 9 is made possible with support of Bank of America, Dana Brown Charitable Trust, Emerson, and viewers like you.